Hello, and welcome to a renewal video, I guess, or refurbishment video of tutorial that I have done 4 years ago. So 4 years ago, I have made this Grasshopper tutorial, Unroll Sesh. There's a typo here, Unroll Mesh Stripes tutorial, where I went through the workflow of how you can make any shape that you want into a series of mesh stripes, right? And also how you can make them laser cuttable. So this tutorial didn't have any sound, and also at this point is very old. So I want to kind of give it a new life, because during the last 4 years, of course, new techniques have emerged and new ways of making these kind of mesh stripes have been done. So we're going to be doing exactly that. Searching the internet, I found this, how do you call it, like a thread, forum thread, where Daniel Piker, amongst other people, have been discussing how we can make mesh stripes a little bit more effective. And the Daniel kind of introduced two approaches, and I'm going to be, well, not stealing, but showcasing, I guess, one of these approaches to you. And that's going to be the multi-pipe stripes approach. This thing right here, this is what we're going to be doing. This is the cleanest approach that I've seen so far of, this kind of a stripe unfolding of any mesh. So I'm pretty happy with it. With that being said, we can jump right into Rhino and start working on this. So this script that I have right here, this is just my notes, and basically I will just be looking at those notes if I get stuck. So first thing to do is to set up some sort of a starting condition on our Rhino file right here. So I'm just going to do something very simple. I'm just going to draw a single line segment that's 1,000 millimeters long, 1 meter, 3 feet ish long, and I will just array polar. I'll just array it along around the center point, this point right here. Number of items 3, that's perfect. Angle to fill 360 degrees, great. So we end up with these three, oops, is that a double? No, we end up with these 3 lines here. For my kind of experiments, I think this is going to be good enough for now. Just having this, and then we can build up in complexity as we go. So I will reference in these curves into Grasshopper, and let's do a quick bifocals thing. You don't need the bifocals, I do. Just for me to show you the curve, like the names of the components. Set multiple curves, we select all 3 of them, and now they are linked. Right, next step, we need to do a multi-pipe right here. So the multi-pipe component will basically just create a sub-D pipes around the 3 lines that we have. Of course, we need to change the node size to something a little bit more reasonable. Let's go for, if this is a meter, let's go for 250 millimeters in node size. Yeah, something like that seems fine. And you can see how clean multi-pipe actually is. Honestly, I'm so impressed with how well multi-pipe works. With this done, we can extract a mesh from multi-pipe. So for that, I will go to Surface, Utilities, nope, Sub-D, Control Polygon, there we go. Select that, place it, extract. So it gives us, and let's hide everything else here. It gives us a mesh representation of that sub-D cage that we have created with multi-pipe. Right, so we're kind of here. This mesh cage, if I were to take the let's say one of the curves, one of the endpoints of the curves, and if I were to move it up, you can see that the mesh cage actually follows that and adjusts to that. I feel like this is quite interesting and quite important to see. Okay, after this is done, so I've just lifted 1 point by some amount upwards. Once this is done, we need to introduce more resolution to this. So we will use refine. Divide each quad into 4 quads and each triangle into 4 triangles. Refine. Let's take a look. That's still not enough polygon, so I'll refine it with level 2//2 to quickly get a panel saying 2, or you can just write 2 and use a slider. Both are fine. Oops. So we connect it, we have it refined. Come on. We have it refined, and if I remember correctly, there was also, yeah, cleanup. So just to be sure that everything is, that there are no double points or anything like that, I will use combine and clean component right here. So these two parts are just basically introducing more resolution and cleaning up the resolution. Then what we will do is we will actually introduce even more. Now when I think about it, give me a second. Let's change things up. So what if we, instead of refining, I always do this and always regret it. Okay, instead of refining, we can use Catmull-Clark. Catmull-Clark subdivision, like that, with level 3, or sorry, level 2. Actually, let's do level 3, or let's do level 2. I keep changing my mind, I know, I'm sorry. Level 2, Catmull-Clark subdivision, and we use combine and clean. So instead of refine, we're using Catmull-Clark. Like that. And then we get a mesh out of this. So mesh, like that. Let me make myself just slightly smaller so that I don't accidentally intersect with the nodes that I'm trying to display. So we have mesh. Next up, we will start building up this solver situation right here. So with kangaroo solver, I always like to, basically we're just going to relax this mesh. So with kangaroo solver, I always like to, what's the word? I always like to work backwards. So I'll use solver. And then solver requires goal objects, reset and on. So reset is a button, always. To be able to reset, you need to press the button. On is a toggle. Always. To have the simulation turned on, you need, this to be double click, true. To have it turned off, false. Goal objects, I always use entwine because it gives me the cleanest input. Stuff arrives in different data branches. Then after the entwine has done its thing, it's going to be spit out here, also as a data tree. So we will want to separate out the data tree with a bang. Or you can use actually explode tree. It's the same thing, explode tree or bang. Like that. Oh, notice how I zoomed in and I added one more input or output. So I zoom in and I press the plus sign right here. And it gives me now 3 outputs. That's because entwine has 3 inputs. I need the inputs and outputs here to match up, or else explode tree is going to complain a little bit. Okay, so in terms of the goals that I want to have, there are 3. Goal number 1 is show the geometry. Right? So this mesh needs to be shown. As easy as that. right? That's my goal number 1. Goal number 2 is I want to introduce warp and wave, like this portion right here. I want to introduce contraction of edges, of mesh edges, along the warp direction, which is along, and wave direction, which is across. So warp, wave, like that. Mesh goes in here. And you can see 2 types of curves are being spit out. And let me show you those. Curve. You can see as I have them selected, this is all of the lines of the mesh in the warp direction and all of the lines of the mesh in wave direction. Does that make sense? There are 2 possible directions for the mesh. For a quad mesh, by the way, it needs to be quad to work. All right, so with this done, then I will specify what's the new line length that I want for the curves in both directions. Line length, or length line, for A and also for B curves, like that. The length for both of them should be 0. Great. But the strength should be different. So I want them to contract, but I want them to contract with different power or different strength. I don't remember how much, but let's just try. Let's just start with 0.5 for the warp and 0.25 for wave, and we will adjust accordingly. So these 2 sliders will be a thing that we will keep an eye out for. We merge the 2 together. There we go, perfect. And we connect them to our Entwine 01 input. So this is our goal number 2, basically saying that some lines should be contracted. In one direction, lines should be contracted more or more heavily. In another direction, the lines should be contracted less heavily. All right, let me hide that. Hide that. What's next? Or also we can hide the mesh. Right here, because it's being spit out here as well as here. There are like many places where it's being spit out. Actually, let's do this. Explode tree 00 output, since show is our 00 input. This is going to be where the mesh is being spit out. So let me just create a mesh component and connect it like so. Perfect. And now we can hide literally everything, and only the mesh component is going to be displayed. All right, last thing is right now, if I let everything contract, I can actually run this. You can see it just contracts to 1 point. Well, that ain't gonna do it. So we need to lock it down. And I'm going to lock down the mesh along its naked points. Naked vertices. Mesh. There we go. All of the naked points are here. And I'll just say anchor. Anchor them in place. And that is going to be our Entwine, the third Entwine input right here. That's it. That's as easy as it is. All of the naked points are literally just the... I can show you. Like that. They're around the openings, right? So they're right here. Okay. So we have ourselves a mesh. Now if I reset and run this, you can see that this, works exactly as what we would expect it to, how we would expect it to work. And now as I play around with warp and wave, I can I can fine tune this to give me a pretty nice shape. After I'm happy with this, I will take a look and decide if I want this to be even denser in terms of the polygons. If I want to, I can do Catmull Clark again on the mesh, and it becomes even softer. Keep in mind that this will simply increase the amount of polygons drastically, which in turn will increase amount of connection points that you will have. So for now, I will not use the Catmull Clark on this. I will look at the mesh as it is, you know, like a naked mesh. Let's play around with the curves now. I feel like it's time. So I'm just going to create a curve right here. So let's see, this is a triangle, and then there is, come on, some sort of a line drawn. Okay, my apologies. Let's continue. I had to stop because I couldn't, I didn't want to continue with a form that we don't have full control over. And I figured out that, well, if the problem is how much it contracts or how little, then we do need to be able to control the length better, right? So I have deleted that 0 panel saying 0, and instead we're going to be using something a little bit more nuanced. So I'm going to be using a multiplication rather, and I'll ask for, okay, what's the length of this curve, for instance, of each of these curves, you know, what's the length? Okay, I get the length and I multiply it by 0.9, let's say. And there's not enough room, so if you want to add room in your Grasshopper definition, hold down the Alt key and just drag on the canvas, and this will just make some more room within the canvas, right? So if I take a length and I multiply it by 0.9, now I have 90% of the original length that I can use as my length input right here. And I can do exactly the same thing in the bottom here. So I'll just say length, multiplication. And I'll use the same slider for both. Like that. When I'm doing this, now I am able to fully control how much the form is expanding and contracting, which is great, right? So now back in here, I can go back and I can change the node size to something a little bit thicker, a little bit bigger, perhaps something like that. Let's just see. And that seems about right. Okay. And then if I reset, I get this kind of an output, and I can work on it with the slider. Right? So I can make it contract more or less. Depends on what I'm trying to achieve. But let's stop it right here and let's just continue working on our definition. So now with this done, or rather this done, as we move forward, we get ourselves a mesh. So this mesh right here, we're basically somewhere around here. And this mesh right here needs to be divided into stripes. And this is where our favorite little tool, and let me hide the curves by the way. This is where our favorite little tool called stripper, I don't know, comes in. So if I use a tool, stripper, and I just connect mesh to stripper, you can see that visually nothing really changes. But then if I were to do this to it, color it basically, use custom preview with a gradient, right? And right click on the gradient to choose amongst presets a color range. Let's say this. Oop, messed it up, doesn't matter. So color range. Then if I were to ask how many strips did it make, list item, basically, oh sorry, not list item, list length. Ask for list list length. I ask for list length, there we go. And I say that, okay, my range, oops, sorry, my range is going to be between 0 and 1, and with list length, I will specify amount of steps in between 0 and 1 to kind of fetch the colors from here. So I'll use range for that. Like so. Range connects to T. Now we have our colors. And then in terms of the strips, if I were to color them just like so, you can see that it does color them, but it's all weird and it's all done in groups. And that's because, you know, just the notion of how stripper works. It produces, like it works in clusters, I guess. It works on the mesh in patches. So we need to fix this. And the way you fix it is by using jitter. Basically, we just take every strip and we change its index number to something else. So jitter is like randomize or shuffle. Shuffle, I guess, is a good word. Jitter, connect it again. Now you can see that the strips are indeed jittered, but the shading is all weird. And the shading is weird because the normals are messed up. So I can use unify mesh, like that. The result goes into the preview. And now finally, if I hide everything, my preview shows the strips and shows them working. All right. So we have this. What now? Actually, do I need the stick right there? Maybe I don't. Let's get rid of this, the line in between, this one right here. Let's just delete it. And of course, this everything is gonna show selected. Everything is gonna complain like crazy. But let me set multiple curves again, reset again. Yeah, now it's fine. Hide this. Now you can see that the stripes are, first of all, they're messing up in certain cases. And the reason why they're messing up is actually has been listed in the thread, in the forum thread that I was talking about in the start of the video. Every single node where you have connections needs to have 3 lines or 5 or 7 lines sticking out from it. If I believe 4 lines messes it up. I might be wrong about this, don't quote me on that, but it seems to be the case here. So if you want to have it even cleaner, make sure that, you know, for instance, we could delete this and then it would be better, but I will not be doing that, at least not yet. So with that being said, let's take a look at the alignment of the strips. Right now the strips are going in this way. I don't want that. I want them to go along the surface. So to make them go along the surface, a very nice tool is called mesh turn. So basically it just turns the order of vertices 90 degrees. So once you do that, then all of your strips align with the directions here. And you get pretty damn long ones. Some of them are pretty damn long. Right? So I end up with something like this. Okay. After this is done, basically this is just going to be, or actually stripper goes here. This portion right here is just the preview portion. We will not be messing around with it. now we are going to actually be talking about the what's the word? The production of this thing. So creating a grasshopper definition that actually makes these strips possible to produce. So let me create a data dam here between the mesh and mesh turn, so that every time when we want to update something, we do need to press the button, or else it's going to become too heavy for us. Now let's create, or let's unroll these strips and place them on the ground. So how do you do that? Well, there are multiple ways. There is the unroll function in Grasshopper by itself, but a much better variation of it, I believe, is Unroll Mesh Stripes tool that is found in Fox plugin that can be downloaded from foodforrhino.com for free, of course. So Unroll Mesh Stripes, there we go, asks you for a mesh. There we go. Unrolls the stripes. Asks us for the unfold value. 1 means that all of them are flat. That's perfect. And asks us, would we like to pack them? Yes, we would. So we toggle, Boolean toggle, turn it to true. And now they're all placed on the ground. And they're all flat. Easy as that. I believe I went overboard with the complexity of this shape. So I actually want to take a step back and delete half of it. Something like that. Because for a tutorial, we shouldn't use overly complicated shapes. So now I'm dealing with something like this. I think this is better. Let's press play. Take a look at it. Yeah, seems to be a little bit better. We're going to stick with this. Okay. And even here you can see that the strips, they're not aligning properly, and that's because, for instance, here we have 1, 2, 3, 4 lines. So actually, to make this work better, I would need to either add 1 more line or remove 1. While here it's fine, we have a point connection with 2, that seems to be good. Point connection with 2 and point connection with 4. So what happens if we add 1 more line? At this point, I'm just investigating the tool. Reset. Let's take a look at the mesh. That will not tell us anything, honestly. We do need to press the data dam. Yep. Now, since all of the points have an uneven amount of edges or lines coming out from them, now the topology is clean, and you can see that the unrolled stripes are also very much clean. So keep that in mind. From points, you want uneven amount of edges sticking out. Okay. Now with this done, we have our mesh, and this is where things get, well, not tricky, but very manual, because we need to make them, laser cuttable. So we need to convert all of this into curves. So the first thing that we're going to do is just extract a Weaver or WB boundary. Okay, fine. We go to Weaverbird tab, extract naked boundary. There we go. We take that, hide the original mesh, and we have ourselves the outlines of each of these stripes. And at this point I can be in the top view, and let's say this is going to be our go-to experimentation strip. So when I've done this, I'm going to say that for every polygon we need like a flap here with a hole to get a rivet through the hole. So there needs to be like a hole on the edge here and like a flap that's holding it, and then the polygons, of course, since they are overlapping or not overlapping, they're touching perfectly edge to edge in the mesh, the holes are going to overlap, right? It just makes sense. Like it's a logical solution. So we're going to be going for that. And the holes, of course, need to be right in the middle. So first of all, I will give it a little bit more breathing room by making the strips a little bit thinner. So offset curve loose, I'll use this, offset curve loose, and I will decide on by how much. Well, let's go for 2 millimeters for the distance, and you can see that it offsets inwards immediately by 2 millimeters. Let me make it bigger for you so that you can see. We'll scroll it down back to 2 millimeters later. So it's offset inwards, but I'm not sure that it will do this every time. Sometimes it might offset inwards, sometimes outwards. So first thing, I'm going to create a plane, XY plane, and connect it here to make sure that it always offsets in the world XY plane. And second thing, for the distance, I have this little trick that I always do to make sure that the offset that I'm making is always inwards. If I have a distance and I have a negative of that distance and I merge them into one list and I flatten this list, or sorry, graph to this list into so that they come in as separate items, I then get a double-sided offset inwards and outwards for each curve. And then once I've done that, I do need to flip matrix so that these two offsets are placed into the same branch. Flip matrix. Just cleaning up a little bit. Okay, fine. Flip matrix. And then I will just simply measure the the length of these curves. Measure the length, sort the length, sort list, and sort the curves together with their lengths so that the shorter one is going to be at the top of the list. And of course, the one that offsets inwards is going to be the shorter one. So list item, I just grab the shorter curve, and from now on, curve, come on, this curve is going to be the thin version. Let me hide all of this crap. This curve is going to be the smaller version, or the inwards offset version of the two possible offsets, right? So this is just kind of a foolproof way of making sure that a closed region offset is definitely going inwards every single time, no matter what. Whew. Okay, so with that done, let's create let's create a circle around every single edge right here. So let me show you. So right here in the middle, a circle, right here in the middle, a circle, right here in the middle, a circle. Let's do that. Well, I will be taking the naked boundary. I will be exploding it. Explode the naked boundary so that I have my segments here. I will use evaluate length for the segments. Exploded segments, I mean. And for the length, I will be using / 0.5, enter. 0.5. So it gives me a center point. And on this center point, I will create a CNR, circle CNR, circle center normal radius. Center point is the evaluated point here. Normal is just Z, so I don't need to add anything here. And radius, well, I can define the radius. Let's see how 3 millimeters would look like. Well, that's very small. Let's do more. Oh yeah, I forgot that here we did 9 millimeters of an offset. No, let's say it's 3 or 2 millimeters of an offset. And the radius, don't forget, it's not the diameter, it's the radius of the circle is 4. So it's 8 millimeter diameter for the circle for the rivets, which is way too much, but hey, I am making a thing that is too big either way. So this is fine, right? Actually, let's, it's so easy to fix it that I should be fixing it. So I'll just take the whole thing and I'll just scale it by half. And here, of course, we need like 180 or something like that. That to be scaled by half as well, the thickness, I mean. Let's press play here. Now everything is kind of smaller, right? And the circles are a little bit more prominent. That's all I wanted to do. Okay, back in here. Radius 3 millimeters, offset 3 millimeters. We can do offset 2 millimeters and radius 4. Sure, why not? Or 3. With the circles done, these are going to be the holes through which a rivet will go through, right? And this is like the inner offset is our the actual boundary of the. Let me hide that. So this is the actual boundary of our strips. So we need flaps that would hold the rivets and the holes of the rivets. So to create this, those flaps, all I need to do is just create a rectangle here, right? Let's actually look at those. So I can do this by simply creating a... let's move these out here because we're gonna be kind of working within somewhere here. So I will be creating how do you call it, like a plane right on the exploded version of these curves. So if I explode the offsetted curves right here, I get their segments, right? And I can use those segments together with the points that I have right here, the exploded points, I believe. Wait 1 second. Yes. Yes. With the exploded points right here, I can create a plane that's called plane line point. As per usual, okay, let's go for sets, not sets, vector, plane, line point. There we go. Create a plane from a line and a point. Okay. So the point is going to be our evaluate length points right here. Right? So the center points right here. Or sorry, no. That's a mistake. Apologies. It's going to be our exploded points right here. And our line segments are actually going to be the line segments right here. So these segments here. And you can see a plane is created on these line segments on top of this point, right? Or rather on top of, like it matches this point with the y-axis and this line segment with the x-axis. All right, so with this being done, now I just need to take this this plane, and I need to orient it from here to the center here, because we're going to be creating a rectangle for a flap. So I'll just say origin, plane origin, this plane to the center point of the circle, right? So I'm just using this point here as my origin, as a new origin. Okay, with that being done, now I have a plane in which I'm going to create a rectangle, and I'm going to just say, okay, let's say my rectangle needs to be centered, and it needs to be 6 millimeters on both sides. For that, I do need to create a the how is it called, domain, not squared, but just construct domain. There we go, which feeds into X and Y. And here I basically just need it to be from negative 6 millimeters until positive 6 millimeters. So 6, negative, goes into A, 6 goes into B, and that's it. We have ourselves a square that you can control the size of, and that is aligned perfectly with the plane. Easy peasy. Okay, so let's go for a 7 or 6 millimeter square on these planes. Now, I need just the outline. I mean, I need all of this to be Boolean, in brackets, Boolean union together. So I'll be using region union, which asks me, okay, what are the curves that you want to union? Well, let me create a merge, and let me say that, well, it's going to be the inner curve here that we get after sorting the list and extracting the list item. You know, the inner offsets, basically. Those are going to be the curves together with the rectangles. And if I measure, or if I check the data tree right here, you can see that it's all a mess because addresses don't meet up. But I can easily fix this by right-clicking and choosing simplify for both inputs. Right-click, simplify, right-click, simplify. It gets rid of the trash from the addresses, and now they meet up. And now if I connect them, this is complaining, but it's complaining because we didn't give it any planes to create the operation in. So I'm just giving XY plane, and now it's happy. And if I hide everything, I here have my circles, and here I have my little flaps, right? Okay, let's make it nicer. Let's use fillet corners, fillet the sharp corners of a curve. That's perfect. And let's give it like 3 millimeter radius for a fillet. It's also good. There we go. We have ourselves some flaps. Next up, we need, like this whole thing is going to be folding naturally, right? So we need to make some dashed lines for the folding. So the way you do it is you just create, you extract the mesh edges from here, from Unroll mesh stripes, mesh edges, and you only get the interior ones, right? So you only get the interior edges here, curve, like that. So basically we have these. Then from the interior mesh edges, you can basically use these together with, or rather you can trim these away with the boundary here. So where's the boundary? The boundary is going to be this curve right here, right? The inner offset. That is going to be the one that's going to be trimming off these little ears from these edges. So we will use trim, trim with region. There we go. The curves to trim are these, the region is this, and honestly I think the plane by default is XY. Never mind, we can use XY plane for trimming, and we get ourselves the output, curves inside and curves outside of the region. If I just type in curve component again, and I just take a look only at the component, you can see that now curves are trimmed. And then I will just say dash pattern like that. And for the within the panel, I will write what's the pattern. So let's say 5 millimeters for the dash and 3 millimeters for the break in the dash. So 5, enter 3, and then click out. Right click, multi-line data, make sure that there's 2 lines here. Connect, hide the curve, and congratulations, you have yourselves a dashed pattern. It's a little bit on the aggressive side, so let's do 4 and 3, something like that. Yep, that's better. Okay, so that's our dash pattern. Now I want all of this. So that's one group. That's gonna be the, the second group. That's gonna be the third group. I want all of these to be within the same group, right? So like once I bake this out, I want all of this to bake out in one big happy family, like as a single group. So I will use merge like that, and I'll connect all 3 of these. What's that? Dash segments, dash segments, like that. So I connect them, and I just look at the output, and I can see that the output is just a complete disaster. Just, you know, addresses not matching, different lengths of addresses, and so on. So I need to fix this. Well, the first thing that I always try is just what happens if I simplify. Again, output, it's better, but it's still not good. And that is because the dash pattern, this output right here, it actually creates, let me simplify, it actually creates a double branching structure. So every branch has 2 branches sticking out from it, rather more than 2 branches sticking out of it. So we need to fix it. We need to merge it back a little bit. So I'll use trim tree to basically get that all of these, all of the dashes that are within the same stripe, I will get them into one data branch. Trim tree will do that, because before all of them were in separate data branches in their own. So this was a data branch, this was a data branch, this was a data branch, and all of those branches were sticking out from a bigger one. So what I did was I just merged back the, well, what's the explanation here? Reduce the complexity of a tree by merging the outermost branches. That's all I can give you. So let me, oops, wrong one. Let me then connect the trim tree into D3, check the output, and now we can see that the data output is actually clean. And I can use group to group the output. And if I were to just select group and hit insert on my keyboard, by the way, insert is quick bake on your keyboards, and I select this, I can see that the whole group gets selected. Neat, isn't it? Okay, so that is kind of done. Now it's final thing. How do you, when you're assembling this, you kind of need to know what's where, right? Which stripe is which. And let's do a very quick one. Let's do a very quick example of this. For the stripper, sorry. For the stripper, we do phase boundaries. We extract the basically all of the polylines out of here, and I will just grab the first polyline within the list item. The first polyline for each stripe, I get it here, and I will ask, okay, what's your center point? Just give me the center area, not area. What was it? Polygon centroid. Polygon center. There we go. Let's create a text tag 3D, or text tag, not 3D, just text tag. CV output is our location. our text is actually going to be series of numbers, you know, starting from 0 and going up. And how much do we count? Well, that's as many of the phase boundaries that we have. Or not phase boundaries, but rather as many as the stripes we have. But with the phase boundaries, it's enough to just calculate the tree statistics. Tree statistics, oops. Tree statistics, there we go. It gives us the count, how many stripes do we have, that's 60. We connect that to the count of series. Now we are counting from 0 until 59, you know, 60 times. Then I right click the S and choose to graft, because this comes in grafted, right? So this needs to come in grafted. And now congratulations, we have numbering, which is very small. If you want it bigger, you can just right click on the tag and choose large numbers. So this is my stripe number 1, or sorry, stripe number 0, right? This one, which coincidentally is going to be this one. So now I need numbering for these, and we will do a very similar thing to this. I will actually just, let's group this, and let me just Control C this, Control V, drag it to, where do we drag it? Here? I don't know. Where did I drag it? I dragged it to the top. Ah, we can drag it to the bottom, that's fine. And actually now we don't need this anymore. Let me delete it because we have the one that I've done now. So for phase boundaries, I need to find the unfolded faces, which are literally the unrolled mesh stripes, right? So I just kind of drag out the long line. Let me get it closer, like that. It connects like that, right? And then I drag it back to here. Delete the text tag, because here the text on these does need to be laser cuttable. So again, we're back to Fox plugin, where we have utilities text, pretty decent. There's also Bowerbird has text, like a text node, and like there's many plugins, but since we're using Fox, we're just gonna keep using the tools from it. Location, again, center point. Text, again, the series. The size of the text, well, right now I don't even know where it is, so I guess it's too small. Let's go for 20 centimeters. I'd say that's a little bit on the big side. Let's go for 2 centimeters, so 20 millimeters. Like that. That seems good. Let's make sure that the text, especially once we're within the teens, that it doesn't stick out. That's a little bit on the close side. Okay, smaller. Let's go for 13. Lucky number 13. Yeah, I think that's gonna be fine. So that's our text. That of course will also be, well, let's simplify it just to check. Yeah, that's gonna be fine. It just connects to D4, gets simplified again, just because I want to keep the simplification here consistent visually. And that's it. That's our groups. And now if I insert them and I just drag them out here, here's my strip number 1 that can be laser cut and can be assembled together with strip number 0, and you can use the 3D model to check what's where. So 1 and 0 connect like so, and of course you just simply, you know, you just align them end to end and they will connect nicely. That is honestly it. Now if I were to say, well, I don't want this, I want to do something much more simple, I've just deleted the lines. Let's say 0, 500, say my one line here, another one here, Something very, very simple. One, two, three. Actually, I'm interested. Would this work? Because technically all of these are 3 lines. I don't see why this wouldn't work. Ah, yes, the inner one is freaking out. And also I forgot to delete the bake. That's interesting. Shall I investigate? Give me a second. Okay, I found out that apparently Unroll Mesh Stripes as well as Unroller, which can be found in Kangaroo 2, both simply do not work with 0.5. Simply do not work with polygons that are not polygons, but shapes that form closed loops of these kind of stripes. So for this to actually work, you would need to somehow you would need to separate out these ribbons into 2, right, into 2 U-shaped ribbons, and then it would work. Because as it is right now, these 2 are complaining, and I don't want to deal with that. So I will simply explode this, take this and drag it out right here, set multiple, play, and you can see now everything, like both of these are working as expected, because there are no enclosed loops. So if you're curious to see how you can actually separate out these polygon loops, leave a comment and I will make sure to show you another follow-up tutorial on this, because this one is getting a little bit too long and I don't want it to be, you know, like 5 hours long. So we're going to be ending here. If you had trouble following along this tutorial, or if you simply don't want to be bothered with it and want to be able to download this definition together with every single definition that I've done on this channel for free, consider supporting the channel and these tutorials with your Patreon subscription. Link in the video description below. So all Patreon supporters get these files, right? Every single file. Right. So I guess that is that. The application of this is pretty clear, and this is a much cleaner solution compared to what we had before. Also, it works much faster. So I'm very curious to see if anyone is actually going to use it. Please tag me on Instagram. I wanna see these being built. Anyway, we're done. I'll see you in the next one. Later.